Hi, today I'm going to talk about the design rule for clearance between the copper and the mounting holes. Normally for different PCB manufacturers, they require different clearance between the copper and this mounting hole that you can define through this design rule. To define that design rule, first you have to define the component class. Press D and C, so it will open component class window. Go here in pad classes and add a new class. Let's call this class non-plated through hole class, and for this you have to choose the non-members holes, and which are this four free one, bring them to the member class. So that's how you can define the here component class, and then press OK. Press D and R, so the design rule window will pop up, and you have to go to electrical, and in clearance you have to add a new rule. Let's call this rule as clearance copper non-plated through hole. Then here where the first object matches, choose the custom query, and right here in pad class, so it will show you automatically an NPTH, and you have to put this in bracket, and then here you have to choose the value whatever you want. So here let's say 1 millimeter. Here you have to apply this to all. Apply, you have to report the polygon. So as soon as you report the polygon, here you can see that this distance between this mounting hole and the copper is 1 millimeter. So let me check the design rule. For that, what you have to do, you have to go to the tools, design rule. So run the design rule. Okay, here we are getting the rule violation and clearance constraint. So this rule violation is between on the multi-layer, and so let me click here. Okay, so this is on the multi-layer and at the edge of the PCB and this hole. Okay, so it says that this distance is less than 1 millimeter, which means that these holes are already very close to the edge of the PCB, and here we have a maximum distance of 0.8 millimeter. So that's why we are getting this this error. So what we can do, either you can shift, if possible on your PCB, then either shift this hole at least 1 millimeter away from the edge of the PCB, so you won't get any kind of design rule error. So let me just report the polygon and rerun the design rule. So, and when I will rerun the design rule check, so I'm expecting that at least I should not get here. Okay, this is not because of this, but this Fujitsu marker. So let me shift this Fujitsu marker to the right side. One more time repo, and let me rerun the design rule. So here, as I have rerun the design rule, there is no error. It's not showing any kind of error here. The rest of the errors are obviously here because I shifted this tooling hole or mounting hole out of my PCB. So as I said, that either you have to increase this distance from the edge of the PCB, or what you can do, let me bring it back to the original position that it was. To open the design rule, press on D and R, so it will open the design rule window, and in this you have to change this 0.8 millimeter what we have seen. That is the maximum clearance what we have on our PCB. So here again you have to report the polygon and run the design rule check. So as soon as I run the design rule check, here you can see that there are no rules violation. So that's how you can define the rule for clearance between the two mounting hole or tooling hole and the copper. Design rule for connectors. the distance between the connector and the edge of the PCB. For example, in my case, I am using here THT connector. As you can see that I have two THT connector. First one is X1 and the second one is X2, and I can define the design rule so that if this distance between the edge of the PCB and the connector is less than the defined design rule distance, then it will show give me a design rule error. For example, in this case, I'm going to put 5 millimeter, and if it's less than 5 millimeter, then it will give us a design rule error. So let me check what is the distance here at the moment. So it's 4 millimeter in this case. So I'm going to define this as a 5 millimeter. So we will get a design rule error. So as you know that this is very simple series voltage regulator. If you have seen my previous videos, then I have already explained this circuit. So let me switch to the 2D mode. Now we are in a 2D mode. What basically you have to do to define this rule, first you have to define the classes for the THT connector, which I already did in my previous videos. You can see that, and but let me show you once again. So what you have to do, you have to go to the design. In design you have to choose classes, and in classes you have to define as a component class which is called THT connector. You have to just here right click and add classes. I have already defined here, and as soon as you define the THT connector as a THT as a component class, it will show you all the non-member component here, and then after that you have to choose the X1 and X2 as member of this class. If you choose other component, then that rule will also apply to those components. That's how you can define the component class. So let me define the design rule. So to define the design rule, go to the design, you have to open the rules, and here in the clearance you have to add a new rule. Right click on the clearance, and then it will show you the new rule. So click on that, and let's call this rule as a clearance between the THT connector and the board contour. So here on the left side you can see that I have defined this new rule, which is called clearance THT board contour, and this rule should be between the between the THT connector and the board contour or a keepout layer. So what you have to do, where the first object matches, here you have to define the custom query. In this custom query, let's write call the component class. In component class, it will, as soon as you write here in component class, it will show you all the classes. So choose here THT, and where the second object matches, here you have to define the layer, and this layer should be a keepout layer. So as the keepout layer and the board contour layer both are at the same place, which means that keepout layer also defines the outer surface of the PCB. So here we have to choose the keepout layer, and here as you can see that the distance is by default it has defined the distance 0.3 millimeter. To change this, what you have to do, you have to first left click here on 0.3, and then you have to hold the left mouse and then choose the values which you have to change. So now it's a 5 millimeter, which is the distance between the THT connector and the edge of the PCB. So apply the rule. Okay. So we have defined the design rule for the clearance between the THT connector and the PCB edge. Normally when these rules apply, then it measures the distance between the edge of the PCB. Let me measure this, edge of the PCB and the edge of your THT connector pin, not at the center of the THT connector pin. So it's like here. So it is around 3.9 or 4 millimeter. Yeah. So to run the design rule, what you have to do, you have to go to the tools, design rules, and then run the design rules. So as soon as I run the design rule, here I'm getting two rule violation. Here as you can see that clearance constraint gap is defined here 5 millimeter, in the design rule, and for the component class TST on layer keepout, and I mean between the keepout layer and the in component class TST. So here it's showing that the distance is 4.597 millimeter, which is less than 5 millimeter, and when you click on this, it will bring you to the to the design rule error point. So let me click here, and here you can see that it's showing you where is the error occurred. So let me move this to the half millimeter right side. So as soon as I will move this half millimeter right side, so let me measure the distance. For example, if I will measure this distance from here till here, yeah, it's more than 5 millimeter. And again, when I will apply the design rule, then I'm not expecting the design rule error. So I have applied the design rule, and here you can see that there is no design rule error. So that's how you can define the design rule for TST or SMT connector, and also for the component. For example, if you have here the component which are on the edge of the PCB and you have to keep some particular distance, in that case also you can make a component class for those component and put those component in like a SMT or TST class, and then apply this the design rule. Design rule for TST connector or Stoco connector, and the classes, how you can define the classes for TST connector or your Stoco connector, and how you can merge them in the polygon. For example, if you have a polygon, say is having a net of ground, and then the ground pin of, for example, in this connector, how we can merge directly into the polygon without thermal relief. That's I'm going to show you. So that is the, I mean, I already did the video for this diode. For example, the pad of this diode, reverse polarity protection diode, how I've merged that here. As you can see that how it's merged in the polygon without any kind of traces. So let's start it. So for that, what you can do, you can just press on P and then polygon per, select that, and then drag your mouse to the right, click till where you want, and then here and skip. You will come out from the polygon pour mode. Then select this, and then here right side you can open the properties of this polygon. That you can do by going to the panel, and in panel here at the corner you have panel, and in the panel you have these properties, either from there or from the view, and then in the view you can go to the, so when you will click here, then the properties of the polygon is open, and you can assign the net either by clicking here as you can see that, or you can also choose assign net from here. So let me do it from here. So once you click here, assign net, then go on your layout and choose the net, which net you have to assign to the polygon. So I wanted to assign this net, and then okay, so the net is assigned. Let me report the polygon. So here, as you can see that the ground is not directly merged in the polygon. It's connected through this thermal relief or through this traces. So that's what we don't want. And you can see that the dead copper is still there, so that you can remove. Again, go to the properties, then choose here pour over all same net object, and choose here remove dead copper. And then again, when you will re-pour this, so as you can see that the dead copper is the dead copper of the polygon is gone, and only the polygon is poured in your board contour area. Okay, come back to this point. So here what you can do, you can go to the design in the classes, and in classes, so classes are basically a group of component. You can choose the component in which group you have to place, so that the specific rule which you will define for the PCB is applied for that group. So like here, as you can see that there are so many classes like component classes, layer classes, pad classes. So the reason is that for this is that you can apply the different rules for these classes, individual rules, PCB rule I mean. So let me here add one more class, and let's call it THT, because I'm having a THT connector which is called through hole terminal. So, and in this THT connector, what you have to do, you have to choose the connector. So here in my case X1 and X2, and then I have to shift this to the right side here, as you can see that. So now we are finished with the classes, and then go to the design rules, and in the design rule define the rule for this THT class, component class. For that, what you can do, you can go to the design, open the rules, and in the rules go to the plane, and in the plane there is this plane which is called Polygon Connect Style, and in that we can define how we have to connect our polygon to different component. And so let me add the new rule, and let's call this new rule as a THT. Okay, and then here where the first object matches, let's call this here choose custom query, and then here to the all nets, and then in constraints we have to choose the simple one, and in the relief connect a style, here you have to choose the direct connection. So that's how it looks like. And then here in the rule you can define, so it's a the syntax for the component class is in component class. Here as soon as you write in, it will open component or component class, and then it will, if you have already defined the component class, then it will show you which class, and then you can choose here THT. This is the syntax for the custom query, and where you have to apply for the every object here in the where the second object matches. So for the all here, as you can see that, then apply. It will take some time to apply, and then OK. So now we are finished with the class definition and the rule. So let me re-pour this. So here, as soon as I re-pour this, as you can see that it has this ground pad or ground connector of X1 is directly merged in the polygon without any kind of thermal relief, and I hope that X2 ground is also. So here you can see that this one is also merged in the polygon. So that's how you can define the class and define the rule for that class for THT connector or Stoco connector in your Altium Designer for polygons. PCB layout electrical rule, that is the clearance constraint between the edge of the PCB or board contour of the PCB and the copper. How you can define a design rules so that on each layer, for example on top layer and bottom layer, and if you have like a 4-layer PCB, then also on the middle layer, either you have the same distance from the edge of the PCB on each layer, or you can also change the clearance according to your need. For example, on top layer, let's say 0.5 millimeter, on first and second layer 0.3 millimeter, and on the last layer bottom layer 1 millimeter. So for that, what you have to do, you have to, here you don't need to define any kind of classes, just you have to press D and R. Design rule window will pop up automatically. So here, as you can see, that design rule window is there. For and now to define the rule, what you have to do, you have to go to the electrical here in clearance, and in clearance then right click, add new rule, and let's call this rule clearance copper board contour. Then where the first object matches, you have to select here custom query, and here you have to write, let me define for the all layer first the rule, and then I will show you how you can define for individual layer. So right here in layer class, electrical layers, because top, bottom and the middle all layers are the electrical layers. And then you have to also choose or is via or is for text and or is pad. So these four things you can define in the custom query here. So this rule applies for all the electrical layers, which means that top, bottom, and if you have a more multi-layer PCB, then for the middle layer also, but not for the mechanical layer. Then this rule apply for the vias, for the text which you write on the copper of the PCB on the top or bottom side of the PCB, and then to the pad of the component. And here where the second object matches, you have to choose here layer, and which layer you have to choose here keepout layer, because that is the same layer where our board contour or the board outline is present. And let me keep it to 0.3 at the moment. Here all this value, apply the rule. So here I will measure the distance, so it's around 0.3 millimeter. And now as we have defined, so now again I will open the design rule, click on D and R, so the design rule window will pop up, and here select all these values, and let's say 2 millimeter. Just type 2 on your keyboard and press enter. Then click apply, OK, and then again you have to repour polygons. So as soon as you will repour, so you can see that the distance from the board contour is changed from the 0.3 millimeter to, we did it for 2 millimeter. So that's how you can change the distance. For example, if you wanted to change the clearance individually for each layer, then click on D and R, design rule window will pop up. And here what we will do, for example, let's say we will change the rule on layer, and let's say here it's a top layer, and instead of layers you have to change it to layer. So, and when I will apply this rule, then I'm expecting that on the top layer the clearance between the board outline and the polygon should be 2 millimeter, and on the bottom side it should be default value, I think, which is here for all layers. Here you can see that, and 0.3. So apply, OK, and then again here you have to repour the polygon. So here I haven't seen any changes on the top layer. So let me measure this distance. So it's 2 millimeter. And then on the bottom layer, here you can see that it's not 2 millimeter. Yeah, so it's 0.3 millimeters from the keepout layer. Yeah. And for example, let me go to the single mode, Shift S. So when I will do the design rule check then I'm expecting here there won't be any uh, design rule error. For that, what you have to do, you have to go to the tools, design rule check, and then run the design rule check. So here, as you can see, that as soon as I did the design rule check, it's giving me the clearance constraint error between the on the multi-layer between the keepout and the these pads which are available on my PCB. So here you can see that if in case these holes are also available on your PCB, then click D and R. So you have to add here design rule and not uh, on layer and multi-layer. So when you will apply this rule, then I hope that there won't be any kind of errors. So apply. So again, design rule check, apply the rules, and here you can see that there are no design rules violation. In case if your rule is not working properly, so in that case what you have to do, you have to go here in the properties and make sure that your clearance copper board contour, this rule is having a higher priority than this clearance. So in this case we have already given the priority of 1, so you don't need to worry. But if this clearance is having a higher priority, which means that this rule is overlooked. So that's how you can apply the design rule for the clearance between the PCB outline or PCB board contour and the polygon copper. Design rule for Fiducial marker. So let me open my PCB layout. Here, as you can see that I have already placed 2 Fiducial markers on my PCB layout, and I also define the design rule. So let me show you how you can define the design rules for Fiducial marker. There are basically 2 important rules, design rules I mean, for the Fiducial markers. The first one is that you have to keep the Fiducial marker away from this keep out layer. So let me go to the keep out layer, and this is my keep out layer, which is the board contour area of the PCB. And the reason to keep the Fiducial marker away from the keep out is that during the milling process, PCB manufacturer should not destroy this Fiducial marker point. Otherwise, what will happen? The component placement machine cannot find the Fiducial marker, and it's difficult for them to place the component to take as a reference point. So that's why. And the second rule for the Fiducial marker is to keep it away from the component pads or from the, for example, from the tooling hole, like that. So for that, what you have to do, you have to go to the design and then open the classes, and in classes, as you can see that I already defined the classes for the Fiducial, but what you can do, you can add here in the component classes, just right click here and then add class, click on that. So as soon as you add new class, the new class will be available, and you just name it Fiducial. So I am not going to add this again as I already added this. So just for the information, I have shown you that how you can define the component class, and then in this class, then you can as soon as you define the class on the non-member side here, you can see the component which are available on your PCB will be shown, and that you can transfer to the right side in the member class of this Fiducial. So that's how you can define the component class for Fiducial. Then let me define the rules. To define the rule, what you have to do, you have to go to the design, you have to select the rules, and in the rule section you have to go to the in electrical and this clearance, and then again you can right click here and add a new rule. So I already added here the two rules for the Fiducial marker. As you can see that Fiducial marker all and Fiducial marker keep out. So let me explain the first rule here. What you have to do, you have to call the Fiducial class here. I mean in the first you have to select the custom query here where the first object matches section, and in the custom query then you have to write just in component class. So as soon as you write in component class, then it will show you all the components, and then in that from there you have to choose the Fiducial and where the second object matches. So here we are going to define for the all the components, and then here you have to define the what is the clearance from track, SMD pad, tooling hole pad, via copper and so on. So here you can define normally for me it's just for the example I put here 0.5, but 0.05 is more than enough, which normally is used in the design. That is the first rule for the Fiducial marker with all the components, and same you can define the second rule. First again you have to add the here go to the clearance, add new rule, and in the new rule make this rule for the keep out. So for the keep out, what you have to do, again you have to write here where the first where the first object matches, you have to define the component class and which is here in component class Fiducial, and where the second object matches, and that is here you have to choose here the layer, and then in the layer you have to choose the keep out layer. But one thing, you make sure that you have already defined this keep out layer, otherwise if you don't define the keep out layer it won't be available here. So here again 0.3 is enough for me, so I'm not going to change this. If you want you can also keep it to 0.5 as per your requirement, but 0.3 for me is enough. Apply, say OK. Let me just self this polygon. So that's how the design looks like, and as I said that my keep out layer is here, which I have shown you already. So here as you can see that if I'm going in the single mode, this is my keep out layer, and this is basically the same as the board contour layer or the outer layer of the PCB. So this layer, normally keep out layer, is useful for defining the rules for like tooling hole and Fiducial marker for such kind of non-electrical component. So that's why normally you have to define this keep out layer. So let me tell you how you can add the keep out layer. You can go to the view configuration, and in the view configuration here in other layer you will get this keep out layer. So let me do the design rule check, and then for example I'm putting this less than, first let me self this polygon. So I'm putting this Fiducial marker less than 0.3 millimeter, so it's around less than 0.3 millimeter, as you can see the distance. Then I'm expecting here a design rule failure for the Fiducial marker between the keep out and the Fiducial marker. So what you have to do, you have to go to the tools, design rule check, and run the design rule check. It will ask you to report the polygon which we self, then report the polygon, and so as you can see that it has given me one design rule violation. And so let me check which is not the distance between, as you can see that here the design rule violation is for modify polygon and not for the distance between the Fiducial marker and the keep out. So maybe the reason behind this is that you have to set the priority in the rules, and that's why it's not taking, maybe this is having a lower priority, then we defined the two rules for the Fiducial marker. The first one was between the Fiducial marker and all the components. Maybe that is having a higher priority compared to the rule which we define between the Fiducial marker and the keepout. So let me again go to the design rules, and in the rules what you have to do, you have to go to here, priorities, click priorities, and you can see that here. Let me expand this. Yeah, so you can see that here the clearance Fiducial marker with all the component is having a higher priority, than the Fiducial marker keepout. So what you have to do, you have to click on this and you have to increase its priority. So as soon as you increase its priority, which means that when the design rule is applied, then first it will check this design rule, which means that the clearance between the Fiducial marker and keepout, and then it will go for the rest of the rule for the Fiducial marker. So close this, then apply and say OK. So this time I'm expecting here the rule violation between the keepout and the Fiducial marker. So again, you have to run the design rule. For that, you have to go to the tools, design rule check, and then run design rule. Report the polygon, and as soon as you report the polygon, so here you can see that two rule violation. And the second is that here you can see that clearance constraint in component class Fiducial and on layer keepout, which means that it's saying that the clearance constraint between the Fiducial marker and the keepout layer should be more than 0.3 millimeter, which we defined. So when you will click here, so it will bring you to that design rule failure. So here it's also showing that the distance between this is our keepout and this is the Fiducial marker, which is less than 0.3 millimeter. So what you have to do, you have to correct this design rule and violation, which means that you have to put the Fiducial marker, increase the distance more than 0.3 millimeter. So, and as soon as you run the design rule, I'm expecting that. So here you can see that as soon as I run the design rule, there is no rule violation for the Fiducial marker here. So that is the first one. So let me put the Fiducial marker near to this component, for example pad of this component, to make sure that 0.05 what we have written should also works the second design rule or not, just to check that. So again, let me apply the design rule. So as soon as I apply the design rule, okay, again I'm getting the rule violation. Here it's saying that the clearance, the rule violation is between in component class Fiducial and all, and it's expecting that the distance should be 0.05 millimeter, but it's 0.015. So as soon as you click on this, it will bring you on the PCB and show you where the design rule is not correct. So just that's how you can apply the design rule for the Fiducial marker. So let me place it at the corner, so it's away from that component, and then again when I will run the design rule check, then there won't be any kind of design rule failure. So it's just the warning which we are getting for the polygon which we saved. So that's not a problem. So let me also restore the polygon, and then report all, and then when I will run the design rule this time, then I'm expecting that there should not be any rule violation regarding the Fiducial marker. So here you can see that. Yeah, so that's how you can define the rule for the Fiducial marker. design rule, clean polygon under SMD component, which means that, for example, if you will see here, here this is the polygon, and which is under this, for example, this diode, or for example here you can see that this is register, and here this polygon is completely under this register. Or for example like this, here you can see that under the Q1 this kind of antenna where this polygon is forming. So how you can remove, or here you can see that this R1 here inside of this R1 register, the polygon is gone inside. So how we can remove all this? To remove all this polygon, what you have to do, you have to first define the design rule for this. And to define the design rule, you have to first define the component class. You have to put all this component where the polygon is under the SMD pads, put all those component in one component class. So let me define first the component class. So to define the component class, what you have to do, you have to go to the design and open the classes, and in the classes here in the component classes, right click and add a new class, add a class. So let's call this class, for example, polygon clear under SMD pads. And under this pad, so we have seen that we have to bring in this member class diodes, Fiducial marker we can leave, transistors, resistance, test points also, and we can leave the connectors. So bring it to the member class and then press OK. So now let's define the design rule for this to clear all this polygon under the SMD pads. And for that, what you have to do, you have to go to the design, you have to open the rules, and in the rules you have to go to here under electrical, this clearance rule, and here right click and add a new rule. So let's call this rule polygon clear under SMD pads. So here you have to choose where the first object matches. Here you have to choose the custom query, and in the custom query you have to write like in component class, and in component class you have to write. It will show you the component classes which you have defined. We defined previously the component class for this design rule, which is called polygon clear under SMD pad. So choose that, and then what you have to do, you have to go to the here in under the constraints, and you have to choose define this copper and SMD pad. In simple, here you have to define, let's say 0.8 0.8 millimeter, and let me check in advance. So under advanced, okay, so here you can see that as soon as you have defined in the simple 0.8, it has already taken also for the field, polygon and region. Okay, so this looks good. So then apply here and okay. So we have defined the component class and design rule for to remove this polygon under the SMD pads. We have to report the polygon. So right click, select the polygon, then right click, and in under polygon actions, report all. So as soon as you report all, so here you can see that the polygon is which was under the Q1, for example, here what we have seen is not anymore there. Here you can see that the polygon is still under the SMD pad under the R1, because maybe this distance is for this case you have to increase the distance. So instead of 0.8, let's do it to 1 millimeter. So let me again go to the design rule and change from 0.8 to 1 millimeter. So here let's change it to 1 millimeter, and in advance I hope, okay, it has already changed that. Yeah, and then again apply, okay. Here then again we have to report the polygon, and as soon as I report the polygon, you can see that here there is no polygon under the SMT pad, and now it's clear. So for example, here you can also see that the polygon is not very close to the SMT pad. So also here in this case you can see that the distance has increased. Yeah, so that's how you can define the rule for to clear the polygon under the SMT component. Let's say you have to apply this polygon clear under SMT pads rule only for one component, that you can also define in the design rule. So let me show you how you can define the design rule only for R3. So open the design rule, go to the design, open the rules. So let me take this example where we have already defined the in component class for a set of components. So let me remove this, and instead of writing here in component class, what you have to write only in component, and then you have to choose which component. So in our case we let's select R3, and then the rest of the rules remain same. So just apply and then OK. Here you have to again report the polygon. So let me report the polygon. As soon as I report the polygon, here you can see that the rule is not applied to Q1, R1 or other components, only to R3. Here you can see that it has applied only to the R3. So that's how you can define this design rule also for the individual component or a set of component. Design rule which is called vias no net, which means that the vias which don't have any net name, with the default design rule Altium Designer cannot detect that. So to detect such kind of vias, we have to define some rules, which I also did for the track which don't have any kind of net name. In my previous video, the link I have provided in the description, so you can check that one also. But here we will talk about this via no net name. So to detect such kind of vias, what you have to do, let me first show you what exactly I mean. For example, so this is my layout for a simple series voltage regulator. If you have seen my previous videos, then I use this schematic to explain the design rule of Altium. So I'm using the same design or same layout. Here you can see that this VI is having net name. Here you can see that, which is called net d1_2. So let me remove the net name from this VIA and I report this. So that's how it looks like. And when I will run the design rule here, so here you can see that it cannot detect such kind of vias. So to detect such kind of vias, for example, if you have a small layout, then maybe you can see such kind of vias. But if you have a big PCB and you have like thousands of vias, then it's really very difficult to detect such kind of to see with the open eyes such kind of vias. So for that, what we can do to detect such kind of vias, we can define the design rule. And to define that design rule, what you have to do, you have to go to the design and then you have to open the rules. In the design rules, you have to go to the routing, and in routing here, routing via style, and here right click, add a new rule. Let's call this rule routing vias no net. Where the object matches, you have to choose the custom query, and we will write here the custom query. So in bracket, so right here like is via. So what basically this query will do, it will check all the vias, then we have to do the combination of another logical expression. Let's say it has to check all the vias, and those vias should be like you have to write here not in any net. So this in any net will return normally. So it will check all the vias which is having a net name, and here we are saying that not, which means that it will return us the vias which don't have the net name. So the next thing is that what we have to do, we have to set the via diameter and the via hole size. So here you have to go for the maximum hole size so that it will cover all kind of vias. So let's say here 100 millimeter minimum, maximum is also 100 millimeter, and preferred is also 100 millimeter, and hole size let's say 90 millimeter, here also 90 millimeter, and preferred is also 90 millimeter. Yeah, so that's how you can define the rule. So here apply, okay. So to apply the design rule, make sure that one of the via is not having any kind of net name. So okay, then to apply the design rule, what you have to do, you have to go to the tools, choose design rule check, run design rule check. So as soon as you run the design rule check, here you can see that it has detected this via which don't have any kind of net name, and when you will click here, so it will bring you to directly to that via. Yeah, so that's how you can define the design rule for detecting the vias without net name. Design rule which is called via under SMD. So how you can define the design rule, that I'm going to tell you. For example, if you have a via and when it is placed on some of the components SMD pad. For example, let me copy this via, and if it's by mistake placed like this. So for example, this via is not having the same net name, then definitely when I will do the design rule check, then design rule check will show me there is a rule violation, clear in constraint and short circuit this rule violation here. But if this via is having the same net name like this pad, then it's not possible to detect that there is a via under this pad. Let me give this via the same net name. So now it's having the same net name. Then report the polygon, and when I will rerun the design rule, so I think it's on the back side. Yeah, so let me report this polygon also. So when I will run the design rule check, then here you can see that it cannot detect that there is a via under the pad. And for that, what you have to do to define this rule, you have to go to the design rules and go to the high speed, and here you will find vias under SMD. Right click, new rule, and let's call this, so let it be via under SMD. Then this rule should be applied to the all component, and allow via under assembly pad. You don't have to click here, otherwise this rule will not work. So apply, okay, and now let me save this. And when I will again here run the design rule check, then I'm expecting that it will show me this, there is a rule violation. So here you can see that as soon as I run the design rule check, it's showing me that there is a rule violation even though this via is having the same net name. So that's how you can define the rule for via under SMD or via under pad. And let me give you one more example. For example, if you have a IC which is having exposed pad with vias, so in that case, for example, if you will apply this rule to that, then it will always give you the design rule error. So to avoid that, what you can do, first let me touch one IC which is having a exposed pad with vias. So for that you can go to the, you can select here in manufacturing part, search ICs, and here let's check this out. Maybe this is having exposed pad and also vias. So here you can see that it's having a 4 vias. Let me report the polygon, and so double click on the IC, so it will open its properties, primitives. You have to unlock the primitives, and then let's call this exposed pad as a ground net, and then this vias, let me select it from the bottom side. Yeah, net, you can select here from the net and then click on the net name which you have to give. So for example, if I will click here, then all these vias got the net name as ground. So let me report this, and when I will do here the design rule check, then it shows me the design rule violations for via size, so which we have defined in our design rule that the via size should be at least 0.4 millimeter. So let me change the size of the via. Here the diameter should be 0.8 and the whole size of the via should be at least 0.4 millimeter. And then let me report this, and this one also. And so when I will run the design rule check, then I'm expecting 2 errors. The first one is for this via under SMD, and the second one is for this R2 via under SMD. So let me run the design rule check. So here, as I said, you can see that there are 2 rule violations. The first one is via under SMD constraint between the pad designators 6 to 29, and then the second one is for the R2. So here in this case, for example, for this chip, you need these vias for the thermal cooling. You can define a design rule so that for such kind of vias under SMD, Altium Designer won't give any kind of rule violation. For that, what you can do, go to the design and then classes, and in the classes here you should first define the new component class. Let's call this QFN24, then bring this component in the member class of this component. So okay, and now what you have to do, you have to go to the design rules, and in the rules you have to here via under SMD. In this rule you have to select custom query and write not in component class. So it will show you the component classes which you have defined, and then you have to choose this QFN24. Apply, okay, and when you will again run the design rule check, then this error won't be there. So here you can see that there is only one design rule violation, and that is for R2, this pad. and not for this one. Yeah, that's how you can define the design rule for the vias under SMD. Design rules for test point. So this is a simple series voltage regulator. You can see that I put some test point in this schematic. So these are my test point, TP1, TP2, TP3, TP4, TP5 and TP6, which I transfer from my schematic to the PCB. Here you can see that those test points. Till now I didn't define any kind of design rules for these test points, so that's why when I'm performing the design rule check, then I'm not getting any kind of error. How you can define the design rule for the test point? There are basically 4 design rules for the test point which you have to define and which are also important for the PCB layout. The first one is the clearance constraint between the test point and the TST connector. If you have a TST connector, for example, in my case, I'm having here this TST connector. So between this TST connector and the test point on top as well as on the bottom. Second, clearance constraint between the test point and the SMD connector on top and bottom. Then the third one is design rule between the 2 test points, that there should be at least 2.54 millimeter distance between the 2 test points so that your PCB manufacturer can do the ICT test. And the fourth one is for the rest of the component on your PCB. So design rule between design rule for the clearance constraint between test point and the rest of the component. So to define the design rule for the test point, first you have to define the test point class. So to define the test point classes, what you have to do, you have to go to the design, and in the design you have to open the classes, and then in classes you have this component classes. By right clicking on the component classes, and then you can add the new class, and let's call this class, I already defined here, let's call this class test point. And in the once you will define the test point, then it will show you all the non-members of this class, and from the non-member of this class you have to select the test point and bring it to the member of this component class. So which you can see here, in my case I already put the test point in the member class of component class of test point. So you can also define here. Then the important thing is that you have to also define the, in case if you have a TST connector or a SMD connector, so you have to also define the class for all those connectors. Here in my case I am only having a TST connector, so that's why here you can see that I already defined the component class for the TST connector, and X1 and X2 are the member of this TST component class. So here if you have a SMD connector, then you can just right click here and add a class and define the as a component class for SMD connector and bring that component in the member class of SMD connector. So in my case I don't have, so I'm not going to define. So let me show you how you can define the design rule for the test point. So to define the design rule, what you have to do, you have to go to the design and then choose design rules, and in the design rules you have to go to the here in the component clearance and right click here and add a new rule. So let's call this rule component clearance between test point and the TST connector, and let's call this on the top side of your PCB. So here what you have to do, where the first object matches you have to select here the custom query, and where the second object matches here also you have to select the custom query. And in custom query you have to write in the first custom query you have to write in component class. As soon as you write in component class, it will show you the component class which you have defined. So here in our case it's test point, And my suggestion is that it's always better to have the test point only on one side of the PCB, either on the top side or bottom side. But I will here define the test point, this design rule on the both side. So in component class TP and on top, and then you have to here define the in component class, and this is TST and on top. In the constraint for the vertical clearance mode, I think we don't need, so you can choose here in infinite. And minimum horizontal clearance, here you have to take for the horizontal clearance between the test point and your TST connector or SMD connector, 2 mm. 2 mm because for example, if you have a TST connector, then you have to keep some space for the machine to press this connector into your PCB, and so that's why this 2 mm we need a clearance constraint of at least 2 mm. And then after that, here you have to select this show actual violation distances, so which means that when the violation will occur, then at that time it will show you how close is your test point near to the TST connector. So if it's not 2 mm, then it will show you exact distance, so you can shift your test point at least 2 mm away from the TST connector. Then let's add the second rule. Let's call this component clearance constraint between test point, TST connector on bottom. So again, where the first object matches, here you have to select the custom query, and where the second object matches, also you have to define here the custom query. And again, here in the custom query you have to write in component class. As soon as you write the component class, it will show you all the classes of the component which you already defined in the classes. And here you have to write it's on the bottom side, on bottom. And then here you have to define the in component class TST connector and on bottom. Then here in the constraint vertical clearance mode infinite, again you have to define here the distance 2 mm, and you have to select this show actual violation distances. Okay, so we have we already defined the design rule for the TST connector. Same you can define the design rule for SMD connector. Instead of TST, you have to just define that is in classes you have to define first the SMD connector as a component class, and here instead of TST we have to choose the SMD. Then the next one is the new rule is component clearance between test point to test point. You have to just select here component class, and you can choose here test point, and where the second object matches, here also you have to define the component class, and you have to choose here test point. And then for this vertical clearance you can define 0.01 millimeter, and the distance between the two test point, if you have seen my previous video, then I've told you that it should be 2.54 millimeter center to center between the two test point, which is sufficient to perform the ICT test. So if you will calculate from the edge of the test point to the between the two edges of the test point, so it comes around 1.34 millimeter. So that is the horizontal distance, 1.34 millimeter. That is the minimum horizontal clearance between the two test point. And then you have to choose this show actual violation distances. The last design rule is component clearance between the test point and all the components which are present on the top side. So all on top. So here also you have to define the custom query where the first object matches, and for the second object matches also you have to define the custom query. Here in the first object matches, in component class test point, and on top, here you have to just define the on top layer, on top I mean. So vertical clearance, in my case it's not important, so I'm not going to define the vertical clearance. If in your case, if it's important, then you can just specify how much vertical clearance you need. Then horizontal clearance for the rest of the component is I think 0.5 millimeter is sufficient. And then again you have to choose this show actual violation distances. You should also define the design rule for the test point on the bottom side. I only defined here, for example, for all the component on the top side. And in case if you are using the SMD connector and TSG both, then you have to also define the design rule for the SMD connector. Or let me define here also for the bottom side. I mean for the all component on the bottom side. So here add a new rule and clearance constraint between test point all and then to bottom. Then here you have to again choose the custom query in component class test point and on bottom, and here custom query on bottom. So whatever the components are available on the bottom side, this rule applies to them. Then select here for vertical, in my case as I don't need, so infinite, and horizontal clearance is 0.5 millimeter, and then select this show actual violation distances. And here you can go and set the priorities for this rule, otherwise the rule won't be applied in a proper way. So what you have to do here, you have to set the give the first priority to the test component clearance between the test point and the TST connector on top. So increase its priority, bring it to the top, and then the second one is test point between test point and TST connector on the bottom. Then if you have SMD connector, then that should be the next. Here in my case I don't have, so I didn't define that. Then the third one is between the test point to test point, and then the fourth one is between the test point and all the other components. That's how you can define. Then say close, apply all these rules. So we have defined the design rule for the test point, and let me show you in 3D mode. I intentionally placed this test point near to the TST connector. As in our design rule we have defined that this distance should be from edge to edge at least 2 millimeter, but here as you can see that it's not 2 millimeter, it's something around 0.5 millimeter. So here I'm expecting that it should give me a design rule error, and here also the distance between the two test point center to center should be 2.5 millimeter. So here I'm also expecting the design rule error, and let me check this distance. So this is also 1.75, which means that we will also get the design error for this test point. And I placed one test point very near to this pad, which we define on the top side, and the bottom side should be at least minimum distance should be 0.5 millimeter in this case. So it's around 0.2 millimeter. So so let's do the design rule check. So you have to go to the tool and then select the design rule check, and here make sure that you have selected the here batch. You have enabled the component clearance, otherwise it will not perform the design rule check for that. So run the design rule check, and here I'm getting 11 rule violations, and all the rule violations are for the test point. Here you can see that this is for the test point, fabrication test point usage, and all the rule violations are for the test point. So here, as I said, that it's also showing you the distance between the two component, which is here between the test point and the TST connector. So here also, and then here, yeah, this is 1.5 millimeter. The distance between these two is 1.5 millimeter, and this is 1.1 millimeter. So let me shift to these two test points away from each other as well as away from the TST connector. This distance should be also at least. So report the polygon, and then again go to tools, design rule check, and run the design rule. So here you have only 6 rules violation, and there is no design rule error for the test point design rule what we have defined. And these 6 design rule violations are, so here 2 of them are, there is a missing test point. So it's showing that why it's this one showing that this fabric missing required test point, because you have defined the test point where your test points are present either on the top side or on the bottom side for the fabrication. So for that, what you have to do, you have to just click on this test point, and here you have to go to the properties test point, and you have to define that this you have to click here on the top side. And when again I will perform the design rule, then I am expecting that there is no error for this design rule. So let's do the design rule. So here you can see that the rule violation is reduced from 6 to 5, and yeah, when you will do that for all the component, then for example all the test points, then it won't be anymore there. So let me select all the test points one by one. In your case, you can use the find the similar object, and from there you can apply. Here in my case, I have a less test point, so I can do individually. Yeah, so when I will perform the design rule, then I'm expecting that there won't be any kind of design rule error. So here you can see that there are no design rule error for the test points, and yeah, that's how you can define the design rule for the test point. Design rules in schematic. So this is a simple series voltage regulator. If you have seen my previous video, then I used this circuit diagram for design rule. Let's say, for example, I wanted to define here in the schematic design rule, I want this ground routing width should be 0.8 millimeter. That you can define in the schematic instead of layout. And to define that, what you have to do, you have to go to the place here in the directives and then choose this parameter set. Place this parameter set on the ground and then double click on the parameter set. So here right side it will open the properties. Let's call it ground, and then here in add, go and add a design rule. So the design rule window will pop up, and here I'm going to define the width constraint. You can also define the other rules if you want. So choose the width constraint and then OK. So it will open this design rule window. Let me change it to the millimeter, and here in the preferred width, let's say 0.8 millimeter, and the maximum width should be 1 millimeter. After writing here the values, you should not press the enter button, otherwise it won't take the values. You have to click on this window somewhere, then only it will take. Otherwise, if you will just press the enter, then it will take the default values. After defining all this width, press OK. And so here, for example, you can see that this rule is defined. So let me bring this here. So here you can see that preferred width is 0.8, minimum is 0.8, and maximum is width is 1 millimeter. Then you have to export this to the PCB layout. So let me show you first my PCB layout. That's how it looks like. This is in 3D view. So this is my ground, and if you will see here, then it's 0.6 millimeter. So when I will do the here the design rule check, then it will let me first import the design rule, that you can either export from the schematic or import from the layout. So import the design rule, execute the changes. So the rule is imported, and when I will do the design rule check, then I should get design failure, because here we have defined the minimum width. This for the ground should be 0.8 millimeter in our design rule. So let me run the design rule check, and as expected, here you can see that rule violations, and these rule violations are width constraint track on top layer, actual width 0.6 millimeter and target width 0.8 millimeter. So when you will click it on this rule violation, it will bring you to the rule violation where it has violated the rule. Then click on this ground net and press tab, so it will select the complete net, ground net. Go to the properties and let's change it to the 0.8. Here I already changed it. Here you can see that it's 0.8, and when I will do the design rule check, then I'm expecting that there won't be any kind of design rule violations. So here you can see that as soon as I run the design rule check, there won't be any kind of design rule violations, which means that this rule, what we have defined in the schematic, is applied to the layout. And when you will go in design and rules, well, you have defined the rules. Here you can see that this rule which you have defined in the schematic is also exported to the layout design rules. So that's how you can apply the design rule in your schematic. Thank you very much.